All right, so before I go any further, I should mention it's normally the usual practice to write both f and g in terms of function. All right, and so I know you said, well, of course, f and g are functions. Well, I said g was this equation 3x plus y plus 2z is equal to 7. But because we want g to be a function, we would define g of x, y, z to be 3x plus y plus 2z minus 7. All right, and so the condition we want is g is equal to 0. Now, of course, that's not going to make a whole lot of difference, but I want you to know that g is also a function of 3 variables. All right, so what do we want? We want the gradient of f to be lambda times the gradient of g, right? So we need to find the gradient of f, which is 2x, 2y, 2z. Very simple. All you have to do is to take the partials of f with respect to these 3 variables. The gradient of g is even easier, 3, 1, 2, okay? And so we will have a system of 4 equations with 4 unknowns. The unknowns are x, y, z, and lambda. And so from this, what we get is 2x is equal to 3 lambda, 2y is equal to 1 lambda, and 2z is equal to 2 lambda. And in addition to that, we also have the equation g is equal to 0, which amounts to 3x plus y plus 2z is equal to 7. Okay, you could say g is equal to 0, but it's the same thing as this. All right, so we have this system of 4 equations with 4 unknowns. Now, this turns out to be a particularly easy system because everything is linear, right? And in fact, all the 3 equations at the beginning are very simple, right? So let's just solve this for x, y, and z. Now, usually, you may have to solve all the equations for lambda and set them equal to each other. That's more typical of what happens. But in a situation like this, you can just divide the first equation by 2 to say x is 3/2 lambda, y is, of course, 1/2 lambda, and z is exactly lambda, right? And the reason you can do it this way, in such a simple way, is because you have this equation which can be expressed solely in terms of lambda right now, right? So 3 times x, x is this, plus y, which is 1/2 lambda, not y, plus, what did I say, 2z, which is 2 lambda. And that's equal to 7, right? All right, so what does this say? This would say 9/2 lambda plus 1/2 lambda plus 2 lambda is equal to 7. And of course, that's 10/2. That's 5 lambda plus 2 lambda, which is, of course, 7 lambda is equal to 7. And therefore, lambda is 1. And that means then x, y, z is equal to x, remember x is 3/2 times 1, and then y is just 1/2, and z is 1. Now the point is, because we plugged in all of these into this final equation, which is our constraint, we know that this point will satisfy the constraint, okay? Because we solved everything in terms of that. We also know, because this is the only point where the gradient of f was a constant multiple, and turns out to be the constant multiplied by 1 because lambda happens to be 1, but it's a constant multiple of the gradient of g, right? So where is this? So this is the only point, okay? This is the only point where you have any kind of a extremum value, which of course in this case is the minimum value, right? Now the reason you know there's a minimum is because you happen to know that this is a plane, and there has to be a point closest to the origin, and that has to be unique. And so we have just found that point. That's pretty cool, right? So I think normally you find that the Lagrange multipliers, this method is easy to set up, and sometimes the system of equations turns out to be difficult. But if it turns out to be easy, like in this situation, then you can solve the problem much more quickly. Okay, so this is it. That's pretty much all for section 4.8, which means that this is the end of chapter 4. What's coming up? Well, at the end of every chapter, you expect an exam. And of course, that's next, all right? But hopefully you have enjoyed this alternative way of maximizing and minimizing a function due to Lagrange, who, by the way, was born in Italy, but has become French, and he was half Italian and half French. And just to celebrate and honor his birthplace of Italy, here's a picture of Venice. And this is a beautiful picture. All right, so with that, I will end chapter 4. And so I hope you will study hard, and I will see you later. Okay, take care. Bye.